You're looking at the mold for the lower hull piece of Fine Mold's kit of the IJN destroyer Ayanami. After weeks of using computers to create 3D designs of all the parts needed, the next step is to actually carve the steel molds.
Suzuki-san was kind enough to open up the tooling here for the hull part of their brand new Ayanami kit. And what I'm holding here is the master. This is bronze, all right? This is the bronze master that was used to carve this area of this tooling via electric discharge machining. We'll take a look at the electric discharge machine here in a moment, but they pass electricity through this to carve out this area of the molding in exactly the shape that the final part is going to be in. But there are areas on here that have no detail, but on the final mold here you can see actually quite a bit of fine detail, and that comes from additional tooling processes, like in this case, like their laser cutter machine, which was used to actually laser in the details that we see here in the bottom of this tooling. This bronze master itself, I can barely hold it up here. This thing's like probably 15 kilos or so right here, and the top half of this tooling alone is about 150, so this is a heavy job.
But before you can carve the mold using the EDM process, you need to make the bronze master to carve it with. These are usually formed by milling the bronze in a computer-controlled machining center, like the Makino V33i, which you're seeing in operation here. That's the same machine, by the way, that Fine Molds released a kit of in 2009.
Wow. This is that part that we put into the machine about 30 minutes ago, and the machine center, based on data that they created at the design stations, has completely, as you can see, cut this part into a very complex shape, all without human intervention in the process. It changes bits and everything to create this. Now this master, depending on the shape, might require additional tooling to clean it up, but in this case, Ishibashi-san here says it's probably going to be able to be used as is. And this will now go into an electric discharge machine, which will be used to use electrical arcing to carve the hardened steel of the actual tools. That is very cool. Mr. Tanimoto has just showed us the Makino Edge 2 electric discharge tooling machine. I think that's what you would call this thing. And we've pulled the master out of the oil here. This is the master. We've already seen how these masters are made in other places. But this master, probably made in the machining center, is attached here, goes down into this oil, and uses electrical arcing, very high voltage electrical arcing, to carve away, slowly but surely, the steel surface of the actual tooling that you can see here inside this oil. The oil carries away the garbage, well, the powder or residue that's left after the surface of the steel is vaporized, and it also helps the electricity flow better between the two parts. The bronze or copper conductor here actually doesn't get destroyed by the discharge process because it's got much lower resistance than the steel piece that's being carved, he has explained to us. But it takes a very, very long time because each zap of the machine only carves away a molecule or so, I guess, of steel, and to go even a millimeter can take 4 to 5 hours of time. So sometimes they actually set this machine and then just go home, and it runs overnight while they're doing it. So that's how many of the finest details are carved into these steel molds. About a year ago when I was at one of the hobby shows, Mr. Suzuki from Fine Molds came up to me and he was like, "Scott, you got to come to our factory again sometime and see our really cool new laser cutting machine." And here we are. It's the laser cutting machine, the LaserTech 40 by Sauer, a German company. Apparently there's only about 200 of these in the entire world, and the basic principle is not unlike that of the electrostatic discharge machine, where you're using electricity to cut into parts. This instead is using laser beam to cut into hardened steel, and because of that you don't need a master. You need the 3D data, of course, but you don't need a master. You just put the 3D data into the machine and it can do the work. Now, it's impossible to see from this distance, but I have an example here of some of the handiwork of this great machine and the men who run it. There's some part of a ship here, and there's this like a tiny little ladder here, and it's not even the size of half of my fingertip. And there's some other detail over in this area too, and all of this was done by this laser machine. If you take a look at some of the other fine molds kits too, you can see a lot of examples of incredibly fine detail in their recent releases, and most of those came out of this little baby right here. We've been getting in the way of the guys at Fine Molds here all day, shooting various machines, and that whole time off in the corner, Mr. Goto here, he's been doing something over here. So decided to ask him what he's doing, and he's been doing fine tuning of the molds, the final versions of the molds. What we have here is basically, well, it's a test shot, which is in effect a rough draft of the final. And if you take a look here, you can see that there's several locations on here where they've got red felt pen marked on the actual parts. And these are areas where we have problems. For example, you can see here that we had a little bit of flange, sticking out from this ejector pin mark here. We've got a little bit of extra flange around this part here, etc. And what he's doing is actually polishing the molds by hand to avoid a repeat performance of this problem. And he's got many tools for doing this. Here's these tiny, tiny, itsy bitsy little files made of some kind of whetstone type of granular material. And it's very, very intense thing that he's doing here, and he's doing it entirely by hand. And that means, of course, that as well as fix problems, if he's not careful, he could make problems. So it's a very, very careful work that he's got to do by hand in order to ensure that the final product is absolutely the best thing they can possibly make. Okay, here comes the fun part. They're actually going to take this mold here for the hull of the new Ayanami. We're going to close it up, put it on, crane it over to the injection machine, and actually shoot some test shots with it. So this will be something really fun to watch.
As I mentioned before, this tooling for just one runner of parts for the Ayanami kit weighs about 300 kilograms, so a ceiling-mounted crane is a must in a factory like this. Almost all plastic kit makers have injection machines in their factory for shooting test shots of what they're making. But when it comes to the actual mass manufacturing of a finished kit, most companies will then ship that work out to another firm which specializes in injection work, using newer and usually partially automated injection machines.
We're standing next to this incredibly hot injection machine here that's all heated up because it's about to shoot plastic at about 240 degrees to 260 degrees Celsius. The actual plastic that goes into it starts out as pellets, like this. And these plastic pellets of styrene plastic go into the hopper up here on this injection machine. Now again, we're looking at a very, very old injection machine that's only used for test shots. But they go into there, they get melted in this gun here, and then zapped into the molds, which you're about to see.
Once the mold is mounted and the machine is warmed up, they can actually start shooting plastic. The injection cycle takes about 20 to 30 seconds or so, from the time the mold closes and the plastic flows, to the time that ejector pins in the bottom of the mold pop the parts out. The parts, still quite warm, are then eyeballed for any problems, and the process repeats.